Section 4.3, the addition rule. One thing to note as we go through this section is that all of these problems involve a single trial, such as drawing a single card from a deck or rolling a die one time. Addition problems will look like this: probability of A or B. Okay, and we have two events, event A and event B, and this or here in the middle is what's telling us that this is the addition rule. Okay, so when it's written like this, we want to find the probability that event A occurs or event B occurs or they both occur. At this point, key thing is that we want to associate that word or with addition. In example 1, we have this table showing a number of students in an introductory statistics course along with their sex and their stated political views. We can see the total for all of these items along the margins here, and we can see that there's 192 people in our sample. The actual question is find the probability that a student identifies as moderate or conservative. So the political views are up top here: liberal, moderate, conservative, and we're interested in these two. These are the moderates, these are the conservatives. Okay, what's the probability that out of these 192 students, we end up choosing one that's from one of those two political ideologies? So 80 of the students identify as moderate, another 27 identify as conservative. So we just add those together and then we divide it by the total number of students. Remember that we round our probabilities to 3 decimal places. When it comes to the addition rule, there's a formal equation. This is an equation that you should memorize because you do need to know it in certain situations. The equation is the probability of A plus the probability of B minus the probability of A and B. And that is really the overlap of those two events. That's just to make sure we're not double counting certain events. So for example, if we're trying to find the probability of drawing a red queen from a deck of cards, we have 26 red cards, we have 4 queens, but there's 2 cards that are both red and queens, and we don't want to count those twice. So we would subtract those 2 out because they're included in both the 26 red ones and the 4 queens. When 2 events are disjoint, also known as mutually exclusive, that means they cannot occur at the same time. Back to using deck of cards as an example, think red cards as one event and clubs as another event. Okay, if we have those 2 categories, we're unable to draw a single card that's both red and a club. Okay, so in some situations, we have 2 events that overlap. Okay, like red cards and kings or red cards and queens. Okay, but if we're talking about red cards and clubs, there's no overlap at all. They're completely separate. They're disjoint, mutually exclusive. We can't draw a single card that satisfies both of those. They can't occur at the same time. So that being said, if we randomly select one of the 92 subjects in this table, would the following events be disjoint? A, getting a subject who is female, B, getting a subject who identifies as liberal. If these are disjoint, they can't happen at the same time. We can't pick just one person and get someone who's A, female, and B, liberal. So in this example, there are a number of subjects who are both female and liberal. If we pick any of those 35, we do satisfy both of those events, so this is not disjoint. Okay, if we said something like, can we get someone who's both liberal and conservative? Those would be disjoint because you can't pick one person who's both liberal and conservative. Example 2b, if we select one randomly selected person from the 192 people in the table, find the probability of selecting a subject who's male or moderate. This time we're going to use the formal addition rule because these are not disjoint events. So when we look at this, let's start off by looking at the males. So we can see that there are 115 males in our table here. Okay, moderates is this middle column. There's 80 moderates. And we can see that there's an overlap between the two, namely this 44 in the middle. Okay, so we would add all 115 of these males, all 80 of these moderates. But when we do that, we're double counting that 44. We're counting it 2 times. Right, so we subtract it out. That's the probability of A and B occurring together. So add 115 plus the 80, subtract that 44 because it's being double counted, divide by the total. That gives us our answer, round to 3 decimal places. Complementary events we covered in section 4.2. Recall that an event and its complement consist of the entire sample space. They add up to 1 or 100%. So the complement of event A consists of all of the outcomes in which event A does not occur. In other words, events A and the complement must be disjoint. It's impossible for an item to be both in event A and the complement of event A. To close things out, let's go back to our table and go through a few questions on complement events. So in part A, we want to find the probability of picking not a conservative. It's not a conservative because we have conservative inside our probability, and then we have that line over top of it. This is also read as find the probability of picking the complement of a conservative. So conservative is this line here. Okay, we can see there are 27 conservatives. That's out of a total of 192. Now this fraction here would be the probability of picking a conservative. The probability of not picking a conservative is the complement of that, so we just want to do 1 minus that fraction. Rounded to 3 decimal places, 0.859. The probability of picking the complement of a male or not a male, if we look at the line for males, we can see there are 115 out of 192. Again, this is the probability of picking a male, so to find the complement of that, 1 minus that fraction gives us 0.401. Part C, the probability of picking the complement of a male is the same as finding the probability of selecting a female. In our table, there's only 2 things here. Okay, so if you're not a male, you're automatically classified into that female category. Okay, that's not the case for these other ones, liberal, moderate, conservative, because there's 3 categories. If you're not conservative, okay, you might be liberal, you're not, you might be moderate. Part D, the probability of choosing someone who's not male is the same as finding 1 minus the probability of choosing a male student. This is the complement rule. It's how we did those problems on the previous slide. Lastly, are the probability of choosing a student who identifies as liberal and a student who does not identify as liberal, are those 2 events complementary? Explain. So we have 85 students who identify as liberal. Okay, the complement of that is everything that doesn't fall into that category. So all these other ones fall into the not liberal category. Together, they total everything in our sample space. They total all 192 students. They are complementary. Students are either liberal or not liberal.